Okay, the next group of problems has to do with factoring and FOILing. So we're going to start off with distribution or FOILing, which is a technique to distribute two binomials like this. So FOIL first of all stands for first, outer, inner, and last. Okay, so multiply the first two numbers together. That's 2x times 2x. You get 4x squared. Multiply the outside numbers. That would be these two numbers. Multiply those two numbers together. The outside number, you get negative 10x. Multiply the inside numbers together, and you get 10x, positive 10x. Multiply the last numbers together. The 5 and the 5. Negative 5. 5 times negative 5, you get negative 25. And then, at this point, you would combine like terms, which is negative 10x plus positive 10x, and end up with just this. That's distribution. And we use the technique FOILing in order to do it. Let's try it again on number 7. Okay? So first times first would be 12x squared. Outside numbers, x. Inside numbers, negative 28 x. And the last numbers, negative 35. So now we'll combine like terms and end up with this. Combining those two, I believe you get negative negative 13 x minus 35. And that's distribution or FOILing. On to the next problem. Okay, so now we're going to do the opposite. We're asked to take this and break it into two factors. So we're going to go like this. I'm going to skip to number 9 because I think if we do number 9 first, it's a little bit easier to explain number 8. So the way you factor a trinomial like this is to imagine the f and the l in FOILing. So what first two numbers multiply to give you x squared? So I'll put an x and an x. The f would end up doing. Ultimately, we'll check this by FOILing. Then, what two numbers can I put here and here that will multiply to give us 9? 3 and 3 give you 9. But be careful, that's positive 9. Yet, when we go to distribute this, we'll have to be negative 6x. So I'm going to just say this is 9 right now. And then we'll do the O and the I. So if we multiply these outside numbers, we get positive 3x, and the inside would be positive 3x. So I'm going to make them both negative. Now let's see what happens. Do the outside, x times negative 3 would be negative 3x, and the inside would be negative 3x. When we combine them, we get negative 6x. So, these two factors, here and here, are the factors of that trinomial. Now, what's different about the problem number 8 is it doesn't have a middle term right here. It doesn't have anything in the middle. This one right number 8 is nothing in the middle. So it's actually what's called a difference of two squares. There's a difference in between these two numbers and they're square rootable. So you'll put x, 7, and 7, and make one positive and negative. All difference of two squares fit that pattern. And if you don't believe me, you can FOIL it up to see if it works. And of course it will. X squared minus 7x for the outside plus 7x for the inside. And the last numbers are negative 3. And to combine these, you get the original. These first cancel out. X squared minus 49. So these are the factors of x squared minus 49. Okay, so now we're going to continue factoring. So I'm looking for a number, a letter times a letter that will give us x squared. That's the f part. And some options for 20. Now there's different things that multiply to give you 20. There's negative 20. There's negative 5 and 4. There's 5 and negative 4. Negative 10 and 2. 10 and negative 2. 20 and negative 1. Negative 20 and 1. Any of these could work, but only one of them actually will work. And the answer is, through trial and error, I found it to be this. Okay? If you FOIL those up, you do first times first times x squared. The outside, negative 4x. And the inside's positive 5x. And when you combine these two, you get positive x, like you're supposed to right there. So this is the answer, x plus 5 and x minus 4. Now on to the next one. Okay, so now this one is a little bit tricky because it looks really complicated, but it's actually not too bad. Now, the first thing you should try when you're factoring is to factor out a greatest common factor, a GCF. Factor out the greatest common factor. Look at all three of these and ask yourself, are they divisible by something in common? What's the greatest number? You can divide them all by 4, right? We can also all be divided by z. They all have at least one z. And so if you divided them all out, all these, 3 of these by 4z, what would remain? And so the way you write it is you factor out the 4z. You pull it outside of all 3 of these. You divide from each one. So now that 4z is out in front. And what's left over is 4 divided by 4 is 1, so there's nothing there. X squared is still there. And then z divided by z is just 1, so it's gone. Plus, the second term, 16 divided by 4 is 4. Z cubed divided by z is just z squared. And the final term, 20 divided by 4 is 5. The z and z cancel and have an x. And so that's actually considered factoring too. These are all different types of factoring you've seen from problems 11 and 9 and 10 and 9 and 8. Different types of factoring. Go back and look at them all. They're all a little bit different. And now we're going to use factoring to solve. So we're going to first factor these problems, and then we're going to find out what value of x makes this equation true. So first the factoring part. So if you have trouble factoring right now, go back to the previous problems. Now this ends up factoring to, let's see, I think negative 12 and positive 2. Those are the factors that work. That's still equal to 0. I just factored the left side of this equation. Now, the zero product property says that any two numbers multiplied together, if you have a times b, and you want it to equal 0, one of them has to be 0, either a or b, right? So we're going to capitalize on that idea. So what I mean is, there's multiplication right here. So what number, when multiplied times this other, will give us 0? So if I put a 12, if x were 12, that'd be 12 minus 12, that'd be 0 times, if 12 is putting here, it'd be 14. And 0 times 14 is 0. So if x were equal to 12, that would be a good solution. It would work. It would help. That would be helpful. There's another one. X could be negative 2. In other words, if you put a negative 2 in here, negative 2 plus 2 would be 0. And if you put a negative 2 in right here, you'd get negative 14. But for negative 14 times 0 is 0. So that would help make this equation true or work. So there's two answers here, 12 and negative 2. Okay, so let's take a look at number 13. Similar problem, a little bit harder because the equation isn't set equal to 0. So let's make it that way. Let's subtract the 24 to the other side, leaving 0 on the right. And now this problem looks a lot like the previous problem. We'll factor it. Factor for positive 6. Oh, excuse me. Factors will be x minus 6 and x plus 4. So another way you'll see some teachers explain this final step is this set of parentheses has to equal 0, or this set of parentheses has to equal 0 in order for the equation to be true. So what you can do is take x minus 6 and set it equal to 0 and solve it by adding 6 to both sides. And you get 6. And you can do the other one the same way. When is x plus 4 going to equal 0? Take away 4, take away 4. You get negative 4. These are your two answers to this problem. These are two values of x that make this equation true.